Hello. In this video, we're going to continue our study of function composition. So let's take f of x as 4x plus 2 and g of x as 3x minus 5. Now, I would like us to find the difference between f of g of 2 and g of f of 2. Now remember, that means we have to plug 2 into either g first or f first, and then take the final result and plug it into the other function. So let's start with this one right here. G of 2 will be 3 times 2 minus 5. So 6 minus 5, so 1. Then we find f of 1. That will be 4 times 1 plus 2. So 4 plus 2, or 6. So f of g of 2 equals 6. Go ahead and pause the video and find g of f of 2. All right, so over here, first we find f of 2. 4 times 2 plus 2, 8 plus 2, so 10. Then we find g of 10, so 3 times 10 minus 5, 30 minus 5, 25. Okay, so this over here equals to 25. All right, f of g of 2 gave 6, g of f of 2 gave 25, and this shouldn't be a big surprise. If anything, this is just a quick recap. Function composition is where you have two functions, and you don't add them or subtract them or multiply or divide them. You take them and you plug them into one another. So you find f of g of 2 means you find g of 2 first, and then find f of that value. And of course, if we switch it around the other way, we would expect it to give us a different result. But now I want us to try it again on these two functions. These are not just any functions. I picked these functions with a lot of care in mind, a lot of thought and a lot of planning went into these two functions. Please find f of g of 2 for me, and then find g of f of 2 and see what you get. All right, let's start off with f of g of 2. G of 2 is 1/2 times 2. Minus 2. So that'll be 1 minus 2, negative 1. F of negative 1 will be 2 times negative 1 plus 4. Negative 2 plus 4, so that will give us 2. Okay. F of 2 is 2 times 2 plus 4. 4 plus 4, so 8. And then g of 8 is 1/2 times 8 minus 2. 4 minus 2, so 2. Oh, weird. They gave us the same answer. These are the same. That's kind of weird, because normally we got something different. Well, maybe it's just a fluke. Maybe it's just a fluke. So go ahead and try a different value instead of 2. Pick your own value. Try 3, 4, 7, whatever you want. Pause the video and give it a try with a different number, and find f of g of that number and g of f of that number, because you should get different answers, right? F of g and g of f, these are not the same thing, and so the fact that we got the same number here, I think is just a fluke. Go ahead and try it with something different. All right, so assuming you tried it with something different, I'm going to try it with 0. I'm going to try it with 0 just for fun. So g of 0 equals negative 2. F of negative 2 equals 2 times negative 2 plus 4, which is 0. Okay. So this here is f of g of 0. Now we'll do g of f of 0. Well, that will be f of 0 is 4. G of 4 is 1/2 times 4 minus 2. Oh, that's 0. And these again are the same. Weird. And I'm assuming that with whatever x value you tried, you also got the same value. This is strange. This seems to totally fly in the face of what we introed the lesson with and what we learned last time. f of g of x is supposed to be different from g of f of x. But in this case, for some weird reason, we're getting the same answer. You know what? let's try to do this with algebra. Let's find f of g of just x. No number, let's do it just with the algebra. Now remember, g of x was equal to 1/2 x minus 2. So, and f of x here, we should write that down as well. F of x is 2x plus 4. So to do f of g of x, we do f of 1/2 x minus 2. And then that means everywhere we see an x, so for example, right here, this x, we replace it with the whole thing, 1/2 x minus 2. So that's going to give us here 2 plus 4. And in place of x, we get 1/2 x minus 2. Now that 2 is going to multiply in to give you 2 over 2x minus 4 plus 4. So that's going to give us x plus 0. So that just simplifies to x. Okay. And what if we did g of f of x? That means we have to find g of 2x plus 4. In other words, everywhere we see an x, we replace it with 2x plus 4. Okay. So we would have 1/2 and a minus 2. And here we'd have a 2x plus 4. We got to distribute that 1/2. That becomes 2 over 2x plus 2 minus 2. So that's just x plus 0. So that just gives you x. And these are the same. These are the same. And the fact that they're both the same means that no matter what x you plug in, you'll get the same answer. If you plugged in 0, you get 0. If you plug in 2, you get 2. If you plug in 100, you get 100. So f of g of x equals g of f of x in this very bizarre situation. But again, I think it's because I put a lot of care and effort into these two functions. Something happened with these two functions. The way I would explain it is it's sort of like f and g are inverses. They're opposites of each other. If you take f and g and combine them, they sort of just cancel out and you just get an x. Or if you take g and f and combine them, they cancel out and you just get an x. It's like, imagine if you put on socks and then you put on antimatter socks. Your antimatter socks would annihilate your socks and then you just have nothing on. You just have your bare feet. And if you did socks then antimatter socks, or if you did antimatter socks first and then socks after, either way you did it, f of g of x or g of f of x, they would both just annihilate each other. They'd be the opposites and you would just be left with the x, just with your feet. So this is a very interesting pair of functions. These two functions, okay, we would call them inverses of each other. These two functions that I selected here, g and f, we would call them inverses. They're opposites. And maybe you can kind of see that, right? This one has a 1/2, this one has a times 2. This one has a plus 4, this one has a minus 2. One's plus, one's minus, one's times, one's divide. They kind of feel like opposites. So let's extend this a bit. Here we have f of x and g of x and h of x. And I'm going to promise you that 2 of them are inverses, and the third one is just kind of the odd one out. So go ahead and do a bit of investigation. See if you can figure out which 2 are inverses of each other. All right, so the way you would do this is you could try to find f of g of x and see if you just get x. But I don't know if you will. F of g of x will give us f of 4x minus 1, which is 4 times 4x minus 1 plus 1. So 16x minus 4 plus 1, 16x minus 3. That's not equal to just an x. So I don't think those 2 are going to pair up. What if we tried g and h? G of h of x is g of x plus 1 over 4. So that's 4 times x plus 1 over 4 minus 1. So the 4's cancel and you get x plus 1 minus 1, which just gives you x. And if you go the other way, h of g of x, you get h of 4x minus 1. So you get 4x minus 1 plus 1 over 4. The 1's cancel to give you 4x over 4, which just simplifies to x. So yes, these two functions, g of x and h of x, they are inverses of each other. They are opposites. They annihilate, and all you're left with is an x. But this raises a very interesting and sort of sad question. I mean, if g of x and h of x are inverses, what about f? Does f have an inverse? If you think about the whole universe of functions out there, is there some function that would pair up with f of x? Is there some kind of soulmate? Some kind of function that you could put with f so that f and some other function together would annihilate and just give you an x? I mean, g of x and h of x weren't the inverses, but does there have to exist an inverse somewhere out there? I'd encourage you to pause the video and give it a try. See if you can find an inverse for f of x. All right, well, let's see if we could kind of construct something here. Looking at these two options, for g of x and h of x, instead of multiplying by 4, we divided by 4. Instead of subtracting 1, we added 1. So maybe we could invent a new function if I'm going to continue the alphabet, f, g, h, maybe I, maybe e, maybe go the letter before f, e of x equal to x minus 1 over 4, because instead of multiplying by 4, we divide by 4. Instead of adding 1, we could subtract 1. And let's go ahead and try that. Let's try f of e of x. That's going to be f of x minus 1 over 4. So 4, x minus 1 over 4 plus 1. 4's cancel, x minus 1 plus 1, which just equals x. And if you tried the other way, e of f of x, it would also work out. So yes, we were able to find the soulmate. We were able to find the inverse of f. And that's super exciting that we found one for f. But we have to keep going. We have to look at another function here. So let's consider fx equals 3 over x plus 4. How would you find g of x? How would you find the inverse? And I mean, I'd encourage you to pause the video and give this a try, but what you're probably going to find is that this function is hard to pair up. It's not easy to find a match for this function. It's kind of one of those functions that just doesn't make friends easily. It's a little awkward. This function, it seems like it's going to need a real special someone, because if you just try a few examples, I don't know if you're going to stumble on it right away. But pause the video and see what you come up with. All right, so maybe you found an inverse, a function that pairs up with fx. But if you haven't, that's all right. I think there does exist one out there, but we're going to need a new technique, because this function here, this is a tough function to match up. And it's not the kind that you can really guess and check with. You need a method. So what's the method? Well, instead of having f of x, I'm going to call this y. So I'm going to say let y equal f of x, just so we're a little more comfortable with like x's and y's. And then what we need is the function that's the complete opposite of this function. In other words, what we're going to do is we're going to swap x and y. So we're going to have a new equation that says y equals 3 over x is now x equals 3 over y. We swap those x and y. And now we're going to do our basic solve for y. Normally we have like a y equals, and because we swapped it around, we don't have a y equals anymore. So let's try to get y equals. We can subtract 4 from both sides, so we get x minus 4 equals 3 over y. Then we could multiply both sides by y. That's going to give you y times x minus 4 equals 3. We could divide both sides by x minus 4. And that's going to give you y equals 3 over x minus 4. Now this function here, which we're going to begin to call f inverse, the opposite of f, will indeed be the function that we're looking for. 3 over x minus 4 will work. And let's go ahead and check. So we have f of f inverse of x would be f of 3 over x minus 4. In other words, we'd have 3 over, right? Everywhere we see the x, replace with 3 over x minus 4. So this gives us 3 over x minus 4. And then we still have our plus 4 out here. Now, this is a bit tricky to do the algebra with, but let's go ahead and do step by step. We'll have 3 divided by 3 over x minus 4. This right here means division, so we can write it as a divide sign. That's going to give us 3 times x minus 4 over 3. Remember, when we're dividing fractions, we simply flip and multiply. The 3's cancel, so we have x minus 4 plus 4. The 4's cancel, and in the end, we just get x. So since f of f inverse just annihilate each other, and we just get x, we've indeed found the correct inverse for the function. So go ahead and give it a try here. We have f of x equals 7x plus 3. Go ahead and find f inverse. So pause the video and give it a try. All right, let's go ahead and do this one quick. We let y equal 7x plus 3. We swap x and y, and then we solve for y. So we subtract 3, divide by 7, and then we label that as our f inverse. Now from here on out, we're not going to bother checking them. So this would be the inverse. As long as you got this as your answer, you're good to go. If you want to check it, you're more than welcome. But now that we have a technique that's going to work every time, we can just go ahead and get the final answer. All right, fx is 2x over 3 plus 5. Go ahead and find f inverse. So pause the video and give it a try. All right, let y equal 2x over 3 plus 5. Swap x and y. Move the 5 over. Now this gets a bit trickier with the 3, because when you do, you have to multiply the 3 to both the x and the 5. So this will be 3x minus 15 equals 2y. And then we divide by 2, and you make sure you write the whole thing over 2. So that gives us y equals 3x minus 15 over 2. And so it's nice to write your final answer as f inverse. So f inverse of x equals 3x minus 15 over 2. Now I've got one more for you here. This one's a bit of a challenge problem. Find the inverse of this function, 6x plus 1 over 3x minus 2. All right, assuming you gave it a try, let me show you how to do this one. So again, your usual step is to let y equal 6x plus 1 over 3x minus 2. You swap x and y, but it does give you a bit of a weird setup because there's y's on the top and bottom. Now to clear this, I'm going to recommend we multiply both sides by 3y minus 2, clear that fraction. And then over here, we actually have to multiply the x in. So we're going to take that x, multiply it in, giving us 3xy minus 2x equals 6y plus 2, or plus 1, sorry. Now, if you got here, good stuff. This is definitely a good start to the question, but we have to isolate for y. Remember, that's our goal. And it's a little tricky, but what I'm going to recommend is we move all the y's to the left side, and we get all of the non-y's to the other side. So to do that, we can subtract the 6y, and we can add the 2x. So those cancel, those cancel. That's going to give us 3xy minus 6y equals 2x plus 1. Next up, we can factor the y from both of these terms, giving us 3x minus 6. And finally, we can divide like normal. Divide out the 3x minus 6. That's going to give us y equals 2x plus 1 over 3x minus 6. And again, it's nice to write our final answer as an f inverse. So f inverse equals 2x plus 1 over 3x minus 6. And there's our final answer. Let's go ahead and take some notes on this. We are learning about inverse functions. Inverse functions. And inverse functions are where you have f of f inverse of x just equaling x. That's how you know it's the inverse, when the two functions annihilate each other and just give you an x. Now, sometimes it's given as f inverse. It could be given as another name, so you could have f of g of x. And as long as that gives you x, and of course the other way, g of f of x, whether it's written as f inverse or written as another function, when they both annihilate, right? You can imagine these two functions. They cancel, right? Or they annihilate each other, and they just leave just an x, just an x. Now the method for doing this, over here, we can see it in our example. Let's try f of x equal to negative 3x plus 2. So you go ahead and pause the video and show the method here. All right, so first we have to let y equal fx. Because if we're going to introduce another variable, we have to state that. Then we're going to do the swap. X equals negative 3y plus 2. Then we're going to do the solve. So here we get x minus 2 equals negative 3y. X minus 2 over negative 3 equals y. And then finally, I like the state. So we have the swap, the solve, and the state. If you like a little alliteration there, f of x, or f inverse of x, equals x minus 2 over negative 3. Now for some extra practice, you can try worksheet 4 and 4.5. And then for any things to remember, probably the most important thing here is the method. You can guess and check, I guess, on some of the easier questions, right? Something like this, you might be able to see here, oh, instead of multiplying by negative 3, you divide by negative 3. Instead of adding 2, you subtract 2. But I would probably stay away from guessing and checking, because you're just as likely to guess wrong and get the incorrect inverse. But it is nice to sort of see in retrospect. It's one of those questions where you can look at the final answer and go, oh yeah, that makes sense. Even if I couldn't have come up with the inverse, now that I see it, it kind of makes sense in retrospect. Another thing you might want to write down, though, is that you can do this with specific values. So f of g of 1 should give you 1. Or if you have it written the other way, f of f inverse of 1 should just give you 1. All right, hopefully you enjoyed this video. And as always, thanks for watching.